Space might seem like a giant, empty void, but the area surrounding Earth is surprisingly packed with objects. Right now, there are more than 8,000 active satellites orbiting our planet, and tens of thousands of pieces of space junk, like old rocket parts, dead satellites, and even tiny fragments from past collisions. With all of this stuff whizzing around at speeds over 28,000 kilometers per hour, you'd think they'd be crashing into each other constantly. But they're not. So, how do we keep all these satellites from smashing into each other up there? First off, it helps to understand that space, even low Earth orbit, is really, really big. Even though there's a lot of stuff up there, most of it is spread out across huge distances. Imagine the Earth surrounded by invisible highways, each one carefully spaced apart. Satellites are like cars in their own lanes. There's so much room between these lanes that they usually never come close to each other, but space isn't left to chance. Everything up there is planned with incredible precision. When a satellite is launched, it's not just tossed into space randomly. Engineers decide ahead of time which orbit it will use. There are different types of orbits depending on what the satellite needs to do. Low Earth orbit, LEO, is commonly used for things like Earth imaging and the International Space Station. Medium Earth orbit, MEOW, is where GPS satellites live. And then there's geostationary orbit, GEO, which is used for weather and communication satellites that need to stay in the same spot in the sky. Each of these orbits is like a specific level in a cosmic parking garage. And within each level, satellites are spaced out so they don't get in each other's way. It's very organized. But just like in real traffic, even careful planning doesn't stop surprises from happening. That's where tracking comes in. All satellites and large pieces of debris are tracked in real time from the ground using radar, telescopes, and specialized sensors. Organizations like the U.S. Space Command, NASA, the European Space Agency, ESA, and even private companies constantly monitor what's up there. They collect orbital data on thousands of objects and use computers to predict if anything might come dangerously close to another satellite. When they spot a potential issue, called a conjunction event, they send out alerts. And yes, when necessary, satellites actually move out of the way. It's called a collision avoidance maneuver. Most modern satellites have tiny thrusters that can make small adjustments to their speed or position. It doesn't take much. Even a tiny nudge can be enough to avoid a crash when you're traveling at orbital speed. These maneuvers are carefully calculated to avoid using too much fuel or disrupting the satellite's mission. Even the International Space Station has to move sometimes. NASA has a specific protocol for what they call debris avoidance maneuvers, where the station boosts itself slightly to steer clear of fast-moving space junk. The astronauts on board are warned ahead of time, and the whole process is well rehearsed. Now you might be wondering, what about satellites that can't move? It's a good question. Some older or cheaper satellites don't have any propulsion systems. Once they're in orbit, they're stuck there. If one of these dead satellites ends up on a collision course, the active satellite has to be the one to move. It's a bit like someone driving around a stalled car in the middle of the road. You just have to steer around it. Of course, space collisions can and do happen. In 2009, a U.S. communications satellite, Iridium 33, collided with a defunct Russian military satellite, Cosmos 2251. The crash created thousands of pieces of debris, which are still being tracked today. Incidents like that are one of the main reasons why tracking and coordination have become such a big deal. And things are getting trickier. With companies like SpaceX launching mega constellations, thousands of satellites all working together to bring internet to Earth, the risk of crowded skies is growing. Space is still big, but we're filling up certain orbital zones much faster than we expected. To keep things under control, space agencies and companies are working on smarter systems. These include AI-powered tracking software, better communication between nations, and even technologies to clean up space debris, like nets, harpoons, and robotic arms. Some satellites are now designed with special sails that help them fall back into Earth's atmosphere and burn up safely when their mission is done. So, how do satellites avoid crashing into each other in space? It's not luck. It's planning, technology, constant monitoring, and a lot of teamwork. From the moment a satellite is designed, its orbit is mapped out, its behavior is monitored, and, if needed, its path is adjusted to keep it out of harm's way. It's like a giant, silent dance happening over our heads. Satellites zipping through invisible lanes, narrowly avoiding space debris, all coordinated by people and machines watching closely from down here on Earth. And the fact that it works, most of the time, is honestly kind of amazing.